Hi, in this video, we will learn how to write an equation for lines in R3. There will be two forms of equations, one parametric, one point parallel form, and we will do some examples for these ones. To write an equation for a line in R3, we actually need two pieces of information. One, well, we have to have a point, let me denote it by P, on the line. So any point on the line. The second thing is a vector, which is parallel to the line. This vector we denote by V, and we will use that to write an equation for the line. So one point and one vector, parallel vector, V. Well, the point is now that, okay, having these two objects for a line, what is the idea? How we can write this equation, or how these guys are describing points on the line geometrically. So let's see what we have here and how we can use those ones to find points on the line. I have a line here and a point P on that. Also, I have a vector V, which is parallel to the line. Now, pick any point on this line. Let's call it X. What we can do here is that we can use P and X and define the directed line segment PX. PX is a directed line segment on the line. As a result, PX is going to be parallel with the vector V. So we have a vector and we have a directed line segment. These are parallel. Well, I want to work with two vectors. I have a directed line segment, and from that I can generate the equivalent vector to Px. We know that such a vector is the vector we get from the endpoint position vector minus initial point position vector. So x minus p will give you a vector. And well, that is going to be collinear with our vector v. In other words, when you find the equivalent vector to px, you basically transfer px such that the initial point of that would be the origin, and then you will have two vectors. Since px was parallel, now the equivalent vector will be collinear with the vector of v. Being collinear means what? Means that one of these guys is multiple of the other one. So there will be a number scalar t such that x minus p is a multiple of b. Very nice. I can play with these. What? Take x, take p to the other side and write this as p plus tb. Well, this way, basically, we said that every single point on the line can be written as p plus t times v for some number t. This number we will call it parameter. And well, for all the other t's, also we get only points on the line. So this is an equation which gives us points on the line, or the position vectors of the points on the line. And this form of equation is called point parallel form. We have a point P and we have a parallel vector V. So we form P plus T. Sometimes to show that X depends on T, we will put a T dependence in front of X. This is one form, and you have to keep this in mind. We will do examples and works on this one. Let me just start an example here. We have a line for which we want to find an equation in point parallel form. What is the line? Let me see. So the line is through point okay, yeah, through point 1, 1, -1, and 2. And the line is parallel to the vector here. This is 2, 0, 1. I have a point P, which is 1 and -1 and 2. And we have a parallel vector V, which is 2, 0, 1. Or write the equation for the line. X, depending on T is equal to P 1, -1, 2 plus T times V, which is 2, 0, 1. I'm just plugging in the above equation. What is P, what is T, and that gives us the point parallel form equation for our line. One thing that we have to add here is that how one can use this equation to find points on the line. Yes, how can one use the above equation to find points on the line? What should we do here? So we already know that, well, P1, -1, 2 is 1 point, but in general, how we can find that, find more points. Everything is here on the variable T, which we call it parameter. For different parameters, you will get different points on the line. So each parameter, any number you choose, any scalar number you choose for T, you will get a point on the line. How does this work? Well, set T, the parameter, to be any real number. Then plug it in the equation. You do some vector operations there. And then you will find the position vector of the point. For example, T equal to 1 means that plug in T equal to 1. It will be 1, -1, 2 plus 1 times 2, 0, 1. This is just component-wise, 1 plus 2, -1 plus 0, and 2 plus 1. That means that for the parameter T equal to 1, we found 1.3, -1, and 3. That is a point on the line. If we set T equal to 0, actually we will get the point that we started with in the equation. So 1, -1, 2 plus 0 times V, which is 2, 0, 1, will give us 1, -1, 2. That's another point which was the original point we used to write an equation. So using parametric, using the point parallel form to find the equation is this: plug in different values for t. Let us now go back to the point parallel equation of the line we have, and let's just play with this thing a little bit. I know that it's going to be x equal to p plus tv. Let's plug in the components, everything. Instead of x, I'll write, well, x, y, z, yes. And that's going to be equal to, well, again, to show the dependence on t, I will put xt sometimes, yt, and zt. P has three components, P1, P2, and P3, plus T times V1, V2, and V3. So this is just, again, vector operation, and what we can do, write this thing, to apply the vector operation, scalar multiplication, and then adding. P1 plus TV1 would be the first component. P2 plus TV2 will be the second component. And P3 plus TV3 will be the third component. Very nice. Now I have 2 points which are equal. Means what? Means that the first component is equal to first component, second component equal to second component, and third component is equal to the third component. I can write these things, the above vector equation, as 3 equations of components. X is equal to P1 plus TV1, Y is equal to P2 plus TV2, and Z is equal to P3 plus TV3. This is another form. We call this the parametric equations for the line. And as you can see, it just comes from writing the equation, point parallel equation, for the components. Let me just write the name here, parametric equations, and this is the second thing you have to know and you have to be able to use for the lines in R3. I box this one, and let us do an example here. Well, actually, the example is the equation we just find in the previous example. We want to write the parametric form or parametric equations for that line. Well, what was the information? We had a point 1, negative 1, 2, and vector 2, 0, 1. So we have 3 equations that's called parametric equations of the line. The first component is going to be first component of the point 1. Okay, I will put the components of P first, then plus add to that T times the components of the parallel vector. The first component goes for the equation for x, so 2. The second component goes to the equation of y, and the third component goes to the equation of z. So let me simplify. This is 1 plus 2t, or I write 2t plus 1. Yt is negative 1, and zt is t plus 2. You have to be able to write the equations of in parametric form for the line also, and you have to be able to understand these both forms and use them in different situations.